Have you ever just stopped and wondered how a chatbot can understand your questions, write a poem, or even translate languages in a split second? I mean, it really does feel like magic, right? Well, today we're going to pull back the curtain and go under the hood to see the brilliant mechanics that actually power modern AI.
So, what is actually going on inside the machine when you type a sentence? It's not about feelings or consciousness, not really. Instead, it's a whole series of incredibly clever steps, all designed to turn our messy, beautiful language into something a computer can actually work with. So let's break it all down.
All right, so the very first hurdle we have to get over is that computers don't see words or sentences like we do. They just see data. So to teach a machine how to read, we first have to chop our language up into little, manageable pieces. This first step is the foundation for absolutely everything that follows.
And this first step has a name. It's called tokenization. The best way to think about it is like this. If a sentence is a big Lego model you've built, tokenization is the process of breaking it down into all the individual Lego bricks. These bricks, or tokens, are the basic building blocks the AI can finally process.
Now, you've got a few ways you could create these bricks. You could split by every single character, but that makes the sequences way too long. You could split by whole words, but then what happens when the AI sees a word it's never seen before? It just breaks. That's why most modern models hit this perfect sweet spot, sub-word level tokenization. It's super efficient, and it can handle rare words by just breaking them down into smaller, familiar pieces. It's the best of both worlds.
So how does that even work? Well, a really popular method is called byte pair encoding, or BPE. It's actually a pretty simple, data-driven idea. The algorithm starts with just individual characters. It scans a huge amount of text and finds the most common pair, like T and H, and it merges them into a new token, TH. Then it just repeats this process over and over and over, building up a super efficient vocabulary from the most common building blocks of a language.
Okay, so the AI has its tokens. It can read the words. But that's only half the battle. Now it has to figure out how they all fit together. Because let's be honest, the order of words is what gives a sentence its meaning.
And this slide just illustrates the problem perfectly. Without any sense of order, a sentence just becomes a bag of words. The computer sees the tokens for dog, bit, and man, but it has absolutely no way of knowing if the dog bit the man or the man bit the dog. That whole grammatical structure is just completely lost.
The solution to this is just so elegant. It's called positional encoding. We literally add another piece of information, a little mathematical vector, to every single token that tells the model where it is in the sentence. It's like giving every word its own unique GPS coordinates. So the AI knows I is in position 1, 8 is in position 2, and so on. Problem solved.
And now we get to the real game changer, the innovation that truly unlocked the power of modern AI. It's a mechanism that lets the model not just know where words are, but to understand how they actually relate to each other. It's called attention.
This quote just nails the core idea. Attention is all about learning to assign a weight or a score of importance to every word in a sentence, relative to every other word. It is how an AI finally learns context.
So here's the crucial part. When the model is processing the word it in the sentence, the dog ate because it was hungry. The attention mechanism lets it look back at the entire sentence and figure out that the most important, most relevant other word is dog. That's it. That's how it connects the pronoun to the noun. It's brilliant.
So how does this work under the hood? Well, you can think of it like a really sophisticated dictionary lookup. Each word sends out a query, which is basically asking, hey, what's relevant to me here? It then compares that query to the keys of all the other words to find the best matches. Then it pulls information from the values of those most relevant words. This whole process creates a rich, context-aware understanding for every single token in the sequence.
And this whole attention mechanism is super flexible. You have self-attention, which is when a model looks for relationships inside a single sentence, like we just talked about, but then you also have cross-attention, which is when it looks for relationships between two different sentences. And this is absolutely essential for stuff like translation, where you have to constantly connect the new sentence back to the original. So, there we have it. We've got our building blocks: tokenization for reading, positional encoding for understanding word order, and attention for grasping context. Now, let's see how these parts are put together to build the powerful AI models we use every single day. You see, these parts can be assembled in a couple of different ways. You've got encoder-only models like BERT, which are designed to understand text. They look at the whole sentence all at once to build a really rich representation, perfect for jobs like sentiment analysis. On the other hand, you have decoder-only models like GPT that are built to generate text. They work one word at a time, looking only at the words that came before to predict what comes next, which is of course ideal for a chatbot.
Now, for a generative model like GPT, here is the final mind-bending challenge. After doing all that incredible work to understand context, it has to make a choice. And get this, at every single step, it's looking at a probability score for over 50,000 possible next tokens. How on earth does it pick just one?
Well, it has a few different strategies. There's greedy sampling, which just picks the single most probable word. It's safe, but it can get kind of repetitive. Then you have methods like top K and top P sampling, which add a little variety by picking from a small group of the most likely candidates. And then there's temperature, which basically acts like a creativity dial. You can turn it up to make the model more adventurous and random, or turn it down to keep it more focused and predictable.
So, let's do a quick recap of our journey. We saw how an AI learns to read by breaking text into tiny pieces using tokenization. Then it figures out grammar and word order using positional encoding, those GPS coordinates. And most importantly, it grasps context with the attention mechanism. All these pieces are then assembled into powerful models that can either understand language, like encoders, or generate it, like decoders. The magic? It's really just layers and layers of brilliant engineering.
You know, this whole thing started with just teaching a machine how to read, and that led to teaching it how to pay attention. The results have already completely changed our world, and that leaves us with one final, fascinating question. Now that we've given machines this incredible power of attention, what new, even more complex ideas will they learn to grasp in the future?